All right, so this question is about thin film interference, and it pertains to interference only due to the phenomenon of reflection. Path difference is not included in the question number A. So if you see this, the upper layer is there, there is an upper layer, there is a bottom layer, and this is the thin film. So if you see the question, the thin film is here, right? So we have to see this thin film layer in this particular question. As you can see, there are two reflecting points. One is marked like this, first reflection, and when this incident ray it reaches the bottom part of the layer, it again reflects back. So this is your second reflection, right? So this is your second reflection. These two rays, ray number 1 and ray number 2, these are two emergent rays. So we have to focus on these two rays to solve this problem. So first of all, you must understand that the phase difference happens because of reflection also, right? How does it happen? What is the thumb rule? The rule is, if you have a refractive index of n1 here and n2 here, and a wave is coming like this, n1 is less than n2, 180-degree phase difference reversal happens. Okay, but if the n1 is larger, okay, so n1 is greater than n2, and this is your n1, this is your n2, and n1 is greater than n2, and the reflection happens off this surface, the phase change, the delta phi which happens is 0 degree. So look at this diagram. This diagram tells you that there are two reflected rays. That is what you need to understand. We have to find the phase difference between the two reflected rays. All right, so let's analyze the situation number 1. This is your first reflection, and from the bottom layer, this is the second reflection. If you notice, the first reflection is happening from 1.5 is n1 here, and n2 is 1.4, right? So you're moving from a higher refractive index to lower refractive index. So no phase reversal happens for 1. So phase difference introduced because of first reflection is 0. If you look into the second reflection here, the phase difference is again 0 because of the second reflection. No phase difference gets created because again 1.4 is greater than 1.3. So both these, first and second, are in phase, right? So there is no phase difference which is introduced between first and second reflected rays, also called as emergent rays. So if you look into the zero phase difference situation, this is correct. If you notice the situation number 2, although this is higher to lower, but the second reflection will happen from lower to higher. So this is wrong. In the first one, higher to lower makes sense. The first reflection will see nothing, but the second reflection which is happening is from lower to higher, because 1.3 is less than 1.5. So here this will get inverted by 180 degree. This will be 0 degree. Therefore, there will be a gap of 180 degree between these two, exactly like this. Here also you will see the same gap. Let's talk about last situation. In the last situation, the first reflection, if you see, is happening from lower to higher. The lower to higher, the first is happening. So this will undergo a reflective phase difference of 180 degree. Let's look into the second reflection which is happening here, right? It is a second reflection happening at the lower point. This is not where the reflection happens. If you consider this one, this also is from higher to lower. So 1.4 is less than 1.5. So again 180 degree difference created between these two. No phase difference will be there. So situation number 4 is also right. So 1 and 4 are the two situations where, despite the two reflections happening, zero phase difference will be there between the two reflected rays. Thank you.